So to get to net zero, we've mentioned these different 6 points we need to address. So let's start with the first one, which is moving to renewable energies. If we look at the energy consumption today around the world, we can see, first of all, that it's increased dramatically from the 60s, the 70s. The Y scale here shows us the amount of energy that's consumed by the world. And today we're still using mainly oil, coal, natural gas. All of these are fossil fuels, which are producing greenhouse gases in the atmosphere. And way below in the bottom of the plot, we can see that the renewable energies are much, much smaller when we talk about the total consumption of energy around the world. So we have a huge challenge if we want to replace the fossil fuels with renewable energies. We've got a long way to go. And here we can see actually what we need to do, because this is continuing to increase in the future as the population grows. We have more people who need more energy, and we need more energy sources for our economies. So we have a huge challenge here of moving away from fossil fuels and replacing this energy with clean energy. Now, the problem and the solution can actually be presented in this very simplistic plot, which we saw also in the first class of the course. What we see here is on the y-axis is the cost of energy to you, to me, our monthly energy bill, how much we pay for gasoline for our cars, the energy to produce our food. The x-axis is time, and on purpose there's no date here. The present is more or less this dashed line, and the two lines here represent the cost of this energy if we use fossil fuels, the red line, or if we use renewable energies, the green line. And what we see is that today, when we pay for our electricity at home, we fill up our cars with gasoline, it's still cheaper for us to use fossil fuels. And therefore, we're on this red line. And so today, it's still cheaper to use fossil fuels to buy electricity, to fill our cars, more expensive to put solar panels on our roofs, to buy electric cars and be on the green line. But the good news is that the red line has to keep on, the price has to keep going up in the future, because it's based on a resource. In other words, it's eventually going to finish. We're going to run out of oil, we're going to run out of coal. It may take another 100, 500, maybe 1,000 years, but eventually it's going to run out. And we're not really certain how much there's left in the ground. As things become scarce, the price goes up. On the other hand, when we talk about innovation and research and development, the price is going to go down with time. We've seen this in all different technologies. You can look at your smartphones, the price that the same smartphone was 20 years ago compared with today. Innovation, technology, research results in the prices going down. And therefore, these two curves have to cross each other one day. Maybe just in a few years, maybe 5 years, could be in 50 years, we don't know. But we and you have to try to change the slope of these curves. The red curve we can push up artificially by putting extra taxation, for example, on the use of fossil fuels. We can double the price of gasoline for our cars so people will take public transportation instead. And the green line we could pull down by giving incentives. The government can give incentives. You can give help people buy electric cars, help them put solar panels on their roofs, and then bring this crossing point closer to the present. And that's part of the policy that we have to use in the future to change and put the real price also for the fossil fuels, include the price of the pollution that it's causing for the environment. So there are ways that we can actually help change the slope of these curves and bring this crossing point closer to the present. And this is already happening. If we look at this plot, which is a little bit noisy, but this shows the price from 1983 onwards for both renewable energies, for different sources, from concentrated solar power, wind, offshore wind, onshore wind, bioenergy. And the little band you could see between the two green lines is the rate of the cost of fossil fuels in dollars per kilowatt hour, the lowest cost and the highest cost. So we see a range of costs around the world. We can see just 10 years ago, solar energy was much more expensive than using fossil fuels. But just in the last few years, the prices have dropped dramatically again through recent research and development, innovation, investment. And today, the prices of solar energy per unit energy are cheaper than all the fossil fuels. And the same with wind energy. So we're reaching a period now that it's much cheaper to produce our energy from solar and wind than to produce it from fossil fuels. And an interesting anecdote is that the amount of energy we get from the sun in 1 hour of sunlight on the whole planet is enough to cover all of our energy needs for an entire year, for all the people on the planet, for a whole year, just 1 hour of solar energy. So we just need to know how to tap into this energy, how to convert this to electricity, to store this energy, to transport it to the places where people need the energy. And this we'll hopefully manage to do in the next decades. There's plenty of energy from the sun out there for all of our needs. We just have to know how to tap into it, how to store it, how to transport it, and to use it in a clean manner. Now, there are problems with solar. We need lots of area to collect the solar energy, and this can cover up regions which could cause environmental damage. Also, the solar panels are not that efficient in converting solar energy to electricity, but there are solutions, and some of them we can see here. For example, in many areas which are open, like roads or parking lots, which could be covered with solar panels. The roofs of buildings and houses could be covered, although some people say this may actually increase the temperature because of the absorption of solar radiation in the city. There's some new projects where the actual roads themselves are made out of solar panels. You actually drive on the solar panels, but it produces electricity from the sun throughout the day. And below these roads, you can even have pipes of water and pipes of hydrogen, which are produced by the solar energy in the middle of the day when we don't need all this energy. Another idea is converting solar energy and solar farms with agriculture. We can maybe put the panels on top of the agriculture, still allowing the light to come in for the agriculture, but also to produce energy, what we call agrovoltaics. And talking about the efficiency, there are new materials being produced. One of these exciting materials is called perovskite, which can also be flexible and transparent, and therefore we can actually make stickers, kind of transparent stickers, which can produce electricity, and we can put them on all the windows of our buildings, of our homes, and produce electricity during the day when the sun is shining. But one of the big problems that people talk about is storage. The sun only shines in the day, so what do we do at nighttime? Here too, lots of innovation, lots of research on different types of storage, not only batteries that we think of normally when you store things in a battery. There's thermal energy storage, electric storage, chemical, electromagnetic storage, and mechanical energy storage. A huge amount of research going on the storage of electricity during the nighttime, because both the sun and the wind may not be blowing all the time. And you can see here on this image that there are different types of capacity of storage, going from 10 kilowatts to gigawatts of power. Some of them also can discharge this energy very slowly, and some can discharge them over days. And just one of them I'd like to point out is what's shown here as compressed air, which is a nice idea. And I point you also to the videos in the additional material you have online that some new companies are suggesting we can actually use the extra solar energy in the middle of the day to compress air into huge containers under the ground. And at nighttime, when we need that energy, we can release the compressed air, which will turn a turbine like a huge balloon, opening a balloon and producing the energy we need at nighttime. So there are solutions for storage, more and more solutions coming online all the time, and we're going to solve this problem of storage in the near future. Now, in addition to solar, we have other types of renewable energy, and one of them is hydroelectric power. This is maybe the cleanest and least expensive source of alternative energies, but, and it's a big but, it's not available everywhere. You need water. And so if you don't have lots of water, you don't have big rivers flowing, then you cannot generate this energy. So some parts of the world, like in the Congo, the Amazon, have huge amounts of rainfall and water, and they can generate hydroelectric power, which is clean, doesn't emit greenhouse gases. But it's a problem if you need lots of water, and it's a problem if the rainfall patterns are going to change in the future, as we've spoken about during the course. One example we see from the Hoover Dam in California, Las Vegas area, which produces huge amounts of electricity from the Colorado River for the western part of the US, especially California, Arizona, Nevada. And because of the huge drought in the last few years, they simply cannot produce electricity anymore, or very little from this lake. And there's also something called the dead pool level, which is the place where the water goes into the into the mechanism to produce power, and for the water to flow downstream. And if the water level goes below this dead pool level, then simply there's no water which is actually flowing in the river downstream, and they're very close to reaching this at the Hoover Dam. So both drought and changes in the climate, changes in rainfall can affect both the water resources, but also the amount of electricity we can generate when we talk about hydroelectric power. Now, one of the alternatives for the future, which is quite controversial, is nuclear power. Now, nuclear is very clean when we're talking about the climate, and it's used in many places already around the world. In France, most of the electricity is generated from nuclear energy. And we should talk about two different types of nuclear energy. There's what we call fusion and what we call fission. Fission is what we normally use in all of our nuclear reactors. And this is basically taking heavy atoms and splitting them. Splitting the atom, this is also what occurs in a nuclear explosion, in a bomb. But we can do this in a controlled environment and produce huge amounts of energy when we split the atoms, like uranium. On the other hand, fusion is the opposite. Instead of splitting, we're actually fusing the atoms together. And this is taking very light atoms, the lightest are hydrogen, and fusing them together to produce something a little bit heavier like helium, and this process also releases a huge amount of energy. Fusion is what happens on our sun. The sun basically is burning hydrogen all the time by fusing this together because of the huge amount of gravity at the center of the sun, producing the energy that we get from our sun, which is running our climate here. In fact, just in the last few years, we've seen the very first experiment where we can successfully get more energy out of the fusion reaction than we have to put in to produce it. Obviously, if we have to put in more energy than we get out, then this is not economical. But maybe in the next decades, we'll see that fusion is also becoming a source of energy to run our economies. We're very far from that. But fission is here. Fission, we use nuclear energy all over the world. People are a little scared of nuclear because they're related with nuclear war maybe. And also we have nuclear waste. We have a small amount of nuclear waste we have to deal with. It's getting smaller and smaller with time. But still, this has to be dealt with. And I should point out that all of the solutions for clean, renewable energies have their problems. Solar energy has problems because of the huge areas we need to cover with solar panels. And what do we do with them after 25 years when we have to change them and recycle them? Batteries are a problem with the chemicals we have to use and the minerals we need inside them. Wind farms are problems with migration of birds. So there's no perfect solution. But if we're talking about what's best for us and comparing it to fossil fuels, all of these are much, much better for the climate than using fossil fuels to run our economies. And nuclear, there's some other interesting facts about nuclear energy. If we look at the amount of carbon dioxide emitted for every megawatt hour produced, if we use a power plant run on coal, then the average power plant will emit about 1,000 kilograms of carbon dioxide for every megawatt hour that we produce. If we look at a natural gas plant, that's about half of that, so it's better. About 500 kilograms of carbon dioxide are emitted for every megawatt hour. But when we go to nuclear energy, zero. For the same amount of energy, we have zero emission of carbon dioxide. We obviously have to build these, which does take up, needs energy and may emit various greenhouse gases. But once it's running, it emits zero amount of greenhouse gases for every megawatt hour that is produced. Another positive aspect of nuclear is the extreme density of the energy. If we look at the size of the uranium pellet of 2.5 centimeters, the size, this can give us the same amount of energy as 480 cubic meters of natural gas, 450 liters of oil, and 1,000 kilograms of coal. So the actual footprint of how much we have to dig out of the ground, where we have to build our power plants, are much, much, much smaller if we're using nuclear energy. And people are worried about the safety of nuclear energy. So here we can actually see for the different sources of energy, how many people have actually died for every terawatt hour of electricity produced based on the air pollution. When we talk about coal, burning of coal and the air pollution, not only do people die in coal mines from explosions in the mining, but the air pollution produced kills the people in the public from breathing the polluted air. So coal is the most polluting, the most dangerous actually, when we're talking about public health and deaths. Then oil, biomass, gas, and you can see down here nuclear, which is at the same level more or less as solar. So it's extremely safe when we're talking about the public health and public safety. Now, until we get to that stage, we saw the huge gap between the fossil fuels we use today and the renewables we're using today. We have to buy some time. It's going to take us time to develop these technologies and to introduce them into our economies, build the infrastructure. So we need to buy time, and this can be done through fuel efficiency. By increasing our energy efficiency that we use in homes, in our industry, in different countries. And we can see here that on this plot, it shows how much, if we use 1 pound of these different fossil fuels, how much energy can we actually get in kilowatt hours. And we see that if we go, say, with wood, when you're burning wood on a wooden stove, or coal, you have much less efficient production of energy. The highest efficiency is actually when we use natural gas. Oil, coal are much less efficient. So for the same amount of pollution in the atmosphere, we'll get a lot more energy from natural gas. But this is not a solution. This is a transition energy until we have the clean energies to use to run our economies. By moving to natural gas instead of coal and oil, it just delays the problem. So if we don't solve this problem, the problem will just be 10, 20, 30 years later, we'll reach the same problem. So moving to natural gas is good on a temporary transitional stage, but it's not a solution to the problem. And again, we can see here, if we just go and we improve the energy efficiency of our buildings, of appliances, of lighting, transportation, industry, we can actually flatten this curve of the increase in greenhouse gases and give us time, maybe 10 years, maybe a little longer, to develop these alternative energies, these clean energies to replace the fossil fuels. Simple things in buildings like improving insulation, keeping in the heat during the winter, keeping it out in the summer. The appliances we buy for our homes, getting the most energy efficient ones. At the lighting, changing lighting at home and in our offices to LEDs. Transportation, also moving more to electric buses, trains, and the same in industry. Just by increasing the efficiency of the use of energy, we can flatten this curve and keep it more or less constant until we find the solutions to go to clean, renewable energies.